Hello everyone, welcome to Business School 101. Today, we're diving into a powerful framework used by data analysts and business decision-makers alike, the OSEMN Framework. Pronounced like the word awesome, this 5-step model outlines the typical data science workflow, making it easier for teams to go from raw data to real business insights. So, what does OSEMN stand for? It's an acronym for Obtain, Scrub, Explore, Model, and Interpret. Whether you're analyzing customer behavior, forecasting sales, or optimizing marketing campaigns, this framework provides a clear roadmap to turn data into decisions. Section 1. Obtain the data. Everything starts with gathering the right data. In this step, analysts collect raw information from a variety of sources: internal systems like sales databases or CRM tools, external sources like public datasets, APIs, social media, or even through web scraping. The goal is to build a comprehensive dataset that can help answer the business question. At this stage, it's essential to verify the data's quality, format consistency, and legal permissions, especially in regions governed by privacy regulations like GDPR in Europe or CCPA in California. Using unauthorized data can result in legal consequences and damage customer trust. For example, a retail company launching a new product might pull data from point-of-sale systems, Google Analytics, email campaign metrics, and customer satisfaction surveys. If the company also wants to understand broader trends, it might integrate market data from third-party research platforms. Section 2. Scrub the data. Once the data is collected, the next step is to clean it. Real-world data is rarely perfect. It may be full of duplicates, typos, missing values, or inconsistent formats. Scrubbing, or data wrangling, is the process of getting the data into a form that's ready for analysis. This step can be time-consuming. Analysts often spend up to 80% of their time cleaning data. But it's critical. No matter how sophisticated your analysis or modeling, unreliable input will lead to faulty conclusions. For example, an online clothing store might find that some entries list sizes as L, others as large, and some in numerical equivalents. Similarly, dates might be recorded in multiple formats. Cleaning involves standardizing these entries, fixing typos, removing irrelevant records, and dealing with missing information, for instance, estimating a customer's age if their birth year is missing but other clues exist. Section 3. Explore the data. With clean data in hand, analysts now begin exploring. This is the investigative phase, where we look for patterns, correlations, and anomalies. It's a creative and visual step, often aided by tools like Excel, Tableau, or Python libraries such as Matplotlib and Seaborn. The goal is to generate hypotheses, uncover relationships between variables, and identify potential features for modeling. This phase informs the next steps and helps businesses ask smarter questions. For example, an e-commerce analyst might notice that sales spike every Friday night and dip on Monday mornings. Or that customers from urban areas are more likely to purchase high-end products than those from rural areas. They might segment users by age group or device type to reveal deeper insights. Section 4. Model the data. Now comes the technical core of data science: building models. Modeling uses statistical and machine learning methods to make predictions or classify data. The choice of model depends on the business goal: predicting future trends, identifying customer segments, or uncovering causal relationships. For example, a subscription-based streaming service might build a predictive model to identify which users are likely to cancel next month. By using logistic regression or decision trees based on past behavior, such as watch time, login frequency, complaints, the business can proactively reach out with retention offers. Other techniques include clustering to identify customer segments, time series forecasting to project future sales, or classification models to detect fraud. Section 5. Interpret the results. Finally, we translate technical findings into actionable business insights. Interpretation means explaining what the model tells us, how confident we can be in the results, and what the next steps should be. It's the bridge between data science and strategy. Interpretation isn't just about numbers, it's about storytelling. Analysts must communicate clearly and convincingly to non-technical stakeholders. This might involve data storytelling, dashboards, or slide decks that focus on implications, not just accuracy metrics. For example, imagine a model reveals that customers under 30 are 3 times more likely to purchase through a mobile app during weekends. That insight could lead the marketing team to run weekend app-exclusive promotions targeting younger users. Last, summary. The OSEMN Framework is a smart acronym in which each letter represents a stage of a data science project. It offers a simple, logical structure for working with data, from raw information to smart decisions. It's not just for data scientists, marketers, managers, and entrepreneurs can use it to guide data-driven thinking. That's all for today's topic. If you found this video helpful, don't forget to give it a thumbs up, share your thoughts in the comments, and subscribe to our channel for more insights on business analytics. Thanks for watching, and I'll see you next time.